All right. So in this video, we're going to look at determining the intervals of concavity and possible inflection points for the given equation, which in this problem is y equals x to the fourth minus 6x cubed plus 1. So when we talk about concavity and inflection points, we're going to need a double derivative. So the first thing that you like to do is find your first derivative and second derivative. The first derivative for this equation will be 4x to the third minus 18x squared plus 0, and you can just leave that plus 0 alone. Then you get your second derivative. So our second derivative here will be 12x squared minus 36x. Okay, so we got our two derivatives. Now what you would like to do is set the second derivative equal to 0 to figure out where would the possible inflection point be. So for us, we will have 12x squared minus 36x is equal to 0. And now you solve for x using factoring techniques. So just by looking at this equation, the 12x squared and the negative 36x, the greatest common factor between them should be 12x. So if you factor out the 12x, you will have x minus 3 remaining in the parentheses. And you can split this now into two equations. You have 12x equals 0, and you have x minus 3 is equal to 0. So for the first case, x is equal to 0. In the second case, x is equal to 3. Right? For the first case, you just divide 12 on both sides, and then the second one you divide by 3. You add 3 on both sides. So these are possible. I'm just going to write this out here. These are possible inflection points. The reason why I'm using the word possible is because if the concavity, when I do the table, if the concavity doesn't change at any one of these values, meaning if it's concave up to the left and the right, or concave down to the left and to the right of any one of these x values, then they won't be considered inflection points. Okay, so all right, we have our possible inflection points. Now you can go ahead and create this table like I mentioned. So your table, the first thing that you want to do in your first row is insert the intervals. So think about the real number line, your real number line R, and plot these numbers 0 and 3. So here's 0, let's say in the middle. Let's say 3 is into the right. What we have from this image here is that the inflection points basically split this real number line, the single line, into 3 parts. The first interval is anything to the left of 0, so that would be negative infinity to 0. The second one would be 0 to 3, that's in the middle. And the last interval would be from 3 to infinity. So those are your intervals. Now for each interval, you want to choose some test values. So you can use any test value that you like, that as long as they are inside of each interval. For example, the first interval, negative infinity to 0, I can use the number negative 1. I could use the number negative 5. I could use negative 10. So I'm just going to use negative 10. For the second interval, I could choose anything between 0 and 3. So something that's very convenient would be 1. And then from 3 to infinity, I'm going to choose 10. All right. Now what you want to do is figure out the signs of y double prime at those test values. In other words, what I want to do is take my test values, negative 10, 1, and 10, and plug them into my second derivative. Now, you have a few options. You could plug it into the 12x squared minus 36x, but because the fact that we only care about the sign for y double prime, I am going to plug it in the factor form. Okay, like for example, if when x is equal to, I'm going to slide this over, when x is equal to negative 10, you get 12 times negative 10 followed by negative 10 minus 3. Well, 12 times negative 10 is a negative number. Oops, sorry. It's a negative number. And negative 10 minus 3 is also a negative number. So when you take two negatives and you multiply them, you're going to get a positive number. And what do we know about positive numbers? Well, positive numbers are bigger than 0. So the sign of y double prime in the first interval, based on our side work there, is going to be that it's positive, it's greater than 0. So one of the conclusions that you can make about this interval is that it's concave down. All right, now we do it for the second interval. When x is equal now to 1, you get 12 times 1, and then 1 minus 3. Well, 12 times 1 is a positive number. 1 minus 3 is a negative number. A positive and a negative, when you multiply it, gives you a negative, which is less than 0. So this will be concave down. And lastly, when x is equal down to 10, yes, the first one's concave up. Oh, I wrote down? Sorry. My bad. I meant to put up. I was already thinking of the second interval in my mind. Okay, thank you. When x is equal to positive 10, you have 12 times 10 and then 10 minus 3. So this is all going to be positive, right? This is positive. This is positive. So this is equal to a positive number, which is greater than 0. So it's concave up. And there we go. We have now the interval. Oh, sorry. We have the intervals of sorry about this. You have your intervals of concavity. In the first interval, negative infinity to 0 is concave up, 0 to 3 is concave down, and then 3 to 0 is concave up. Now remember, I did make a comment saying that these values 0 and 3, they were your possible inflection points. Now to the left and to the right of 0, the concavity changed. And to the left and to the right of x equals 3, the concavity also changed. So the inflection points exist at x equals 0 and x equals 3. If you actually want to figure out what those inflection points are, like actual coordinates, you would have to plug 0 and 3 into the original function, right? Like, for example, if I plugged in 0 into the function, you would get 1 because 0 to the 4th minus 6 times 0 cubed plus 1 is 1. When x is equal to 3, you guys got to do a little bit more work. So 3 to the 4th is like 81. Then for the next number, 3 cubed is 27. So 27 times negative 6. I don't know what that is off my head. I think like negative, let's see, 3. I said negative 27, right? So negative 6 times 20 is negative 120. Negative 6 times 7 is negative 42. So that'll be like negative 162 plus 1. So it's like about 80, I want to say. Somewhere like around 80. So like 0, 80 maybe. You'd have to double check that with a calculator. But those would be technically your inflection points as order pairs. All right. And that's how you answer problem 12.